When we left today, there was a couple things we didn't finish. You guys, being that you're not going to be in class the next couple days, I told you I'd post something online here regarding an assignment. So here is an assignment. We'll take this as I don't know if you're not going to be here tomorrow or Friday, then I guess we'll have this due Monday. We'll kind of play that by ear. I gave you odds so that you have access to solutions and you can see how things are going. That should help you along. But what we didn't have time for, and I wanted to give you guys a quick demonstration, was horizontal shrink versus horizontal stretch. So what I think I'll do to show that to you guys is let's just consider the basic function y equals x squared. All right, I think a good way of showing this is I'll make a table for this function, just a basic table at, let's say, -2, -1, 0, 1, and 2. We plug those in, we know that we get 4, +1, 0, 1, and 4. So that's going to be the reference. That's going to be the one that we're going to compare the others to here. So now we'll take a look at what the graph y equals 2x squared will look like. And the other one we're going to look at is y equals 1/2 x squared. Okay, so what are these going to look like? How does horizontal shrink and horizontal stretch apply here? So I think a good way to show this, like I said, look at the table. And for this one, y equals 2x squared. I'm going to do the same x values. Okay, we plug those x values into this function. We are going to get +16 for this because we have to take -2 times 2 up here. That's -4. We have to square that. That's 16. So complete the rest of the table here. We get 4, 0, 4, and 16. So we look at this. This is called horizontal shrink. The graph is being shrunk horizontally. And how I can demonstrate that to you is it used to be the case, if I look at the original graph, let's just say at the ordered pair -2, 4. I used to have to go left 2 places from the center in order to get to the y value of 4. However, when I look at this function, the one that we just did, I now only have to go 1 over. So it can be thought of as the graph has been shrunk horizontally. It's been squeezed horizontally. So we call this, or our book, I should say, calls this horizontal shrink. The graph has been shrunk horizontally. The other one over here, y equals 1/2 squared. We can look at a table of values for that. However, this one I'm going to slightly change the x values because I don't want to get decimals. I want to leave whole numbers so that it's easier for us to talk about and look at. So for that reason, if you think about this long enough, you'll see why I did this. I'm going to go -4, -2, 0, 2, and 4. So when I plug those in to the function here, I replace x with each of those. I'm going to get the values of 4, 1, 0, 1, and 4. And I'm going to do a similar thing here. We can look and compare to the original. Let's just compare to the same ordered pair as we did here, -2, 4. Okay, now to get to the y value of 4, I have to go left 4 places. So I have to go further away from the 0, from the y-axis, in order to get to the same y values. So this is called horizontal stretch. So some of the problems are going to ask you to compare graphs to the basic graph. And what we're talking about is y equals x squared is one of the basic graphs. So is the square root of x. So is the absolute value of x. And so the idea here is that we want to have an understanding of how those graphs get changed when we add numbers and stuff to them and make them look a little bit more complicated. Our goal is that you can look at those equations and understand what they look like with respect to the basic graphs here. So, once again, in case you missed it, We're going to try these problems, 3 to 11, 27 to 43. They're all odds. Feel free to do some even problems, and you can ask me about those as well, but I wanted you to have a nice set of problems that you can check answers and see what's going on. So that when we meet again, for some of you that's going to be next Monday, and for others it'll be tomorrow, but we'll be able to go from there with this, okay? Hope this helps. Talk to you guys soon.